Okay, so today we're going to be talking about the ketones. Ketones are organic compounds that contain the functional group called carbonyl. Carbonyl is a functional group that has specifically a double bond with oxygen. Okay, in and one of the carbons, actually in a secondary carbon. Okay, because if this functional group, which is the double bond with the oxygen, is in an ending carbon, is not a ketone, it's an aldehyde. So ketones and aldehydes share the same functional group, ketones and aldehydes. Okay, if the functional group is here, then, and by here I mean in any of the secondary carbons, and you know that a secondary carbon is one that is connected to two other carbons. Okay, so this is secondary because it's connected to this and this other carbon. This is also secondary, but this is a primary carbon. So when the chemical, when the functional group, the carbonyl, is attached to the primary carbon, is an aldehyde. It's not a ketone. In the middle, if you will, is a ketone, and one of the ends is an aldehyde. But let's talk first about the ketones. The ketones, again, contain this functional group called, oh boy, come on, you can do much better than that. Okay, there you go. Let me put it here. If I have this compound, for example, what would be the name? Well, the name is the same thing as the alkane that forms this compound with the ending O-N-E, own. For example, here I have 1, 2, 3, 4, 5, 6, 7, 8. I have 8 carbons. Therefore, the compound is going to be an octane. Now, I have the functional group in the third carbon. Remember, I have to start counting from the end that is closer to the functional group 1, 2, 3. So I can call this 3 octanone. Octanone. That's the name of this compound. Bam, period. That's it. Or I can also call this very compound this way. Is here, I can make this like the division of these two radicals. I could count this as a ketone, and then to the left I have 1, 2, 3, 4, 5, and I have to the right 1 and 2. So I will have ethyl pentyl ketone. Okay, ethyl because I have a branch that has 2 carbons to this side, pentyl because of the 5 carbons that I have to this side, and ketone because this is the functional group for the ketones, if you will. Okay, so if I say 3-octanone or I say ethyl pentyl ketone, I refer to the same thing. Do you understand this? Any questions?
Can you, why would you say ethyl pentyl ketone?
Oh, remember, I have to respect the alphabetical order. I could have said pentyl, ethyl, ketone, but then I would be disrespecting the alphabetical order. E comes before P, so I just say ethyl pentyl ketone. Did I
Wait,
answer your question, or you were talking about something else?
isn't the longest chain 8? So why would you use pentyl?
Oh, because you don't take into account the the one in the center. Let me repeat what I just said. Because here you have this guy. This is like the center of it. This is the core, and then whatever is connected to this is going to be named as a branch. So if you count to the left, I have 5 carbons. To the right, I have 2 carbons. That's why I have ethyl and pentyl connected to the ketone. I don't know if I answered your question, did I?
Yes.
Okay, any other questions? Any other question?
Not right now.
Okay, so you're planning to ask me later, huh?
Possibly.
All right, let's see if I find here. Okay, let me do it this way. What if I give you now a name? If I give you a name, will you be able to give me the formula for that? If I tell you, for example, butyl propyl ketone. Is anybody able to draw this formula here for me? Can anybody draw this formula for me here? Anybody wants to give it a try?
I could try.
Yes, please try. Go ahead. Are you trying? Mm-hmm. Okay. Okay. What is another name that I could give to this compound? Can anybody tell me? Romeo, Charles, Bianca, is there any other way I can name this very compound? Royan, you tell me when you're done. Are you done?
Yes.
Okay. Double check it because something is wrong here. Now the other people, can you tell me the other possible name for this? No?
Oh.
You found it? You figured it out?
Yeah.
Okay. Charles, Romeo, Bianca, what is another name for this? Okay, much better now. Much better now. What is another name for this?
I know.
Okay, tell me because the others are kind of, what is the name for this?
Octanone.
Okay, yes. Yes, that's correct. And also, let me tell you something. This can also be named, and listen everyone, Charles Romeo, I expected you to know this, is a 4-octanone because in the fourth carbon, you have the functional group, and you have 4 carbons in the longest chain. Okay? So if I ask you later,
Great.
I hope you're able to tell me. Okay, now this can also be called octane dash 4 on. And this, same thing, this can also be called octane dash 3 on. This means the same thing. It's an octane that in the fourth carbon have the functional group for the ketones. All right? Yes? So instead of only
Yep.
2 names, you can have 3 different names. Let me give you something here to see if you can name it. Now I'm gonna give you a next formula and you will tell me if you can name it. Okay, I'm gonna delete everything here, can I? Or you need it for reference? I'm gonna leave it because I know that some of you might need it. Okay, so how would you name this? Give me the 3 possible names for this. Remember that here you will have some dashes. Let me put it here. The bonds are here. Oh boy. In the meantime, you can start thinking on the name for this. The 3 names. I suggest to take the easiest one so that you don't have to go through the hardest one. What's the name for this? Hola, is anybody home?
4, 5. I lie. 3. Heptanine, heptanone.
Heptanon. Okay, next person. The next name. Next person.
Hepta 3-one.
Hepta 3
Yeah.
own. Very good. Next person. We still have a next name. So Romeo or Charles. Hola.
I honestly don't know what I'm looking at.
I'm sorry. Charles, can you tell me the name for this one?
Charles's mic doesn't work.
Okay, can he type it on the chat at least? Or his keyboard doesn't work neither? Okay, we're wasting time here. We need to move on.
I got it.
Okay, tell me.
Oh.
You could go ahead, Bianca.
Okay, somebody
No, but I
type it
might
on
be
the
wrong,
chat
so
for
go
me.
ahead.
Okay, you're lost. When did you realize you were lost, Charles? You can't tell me just now that you're lost when I've been explaining this and asking if you had any questions. It's just now when you realize that you're lost? Go ahead, tell me, Royan or Bianca, whoever.
Ethyl butyl ketone.
Next try, next person.
What do you mean wrong? That was what I was gonna say.
Okay, both of you wrong then. Are you taking into account the alphabetical order here or not?
Oh, butyl
Oh.
ethyl ketone.
Okay, so we're talking about the same compound when we mention any of these names. This, all right? I'm gonna give you a name now, and I hope you're able. Charles, what is the part that you don't understand here? Can anybody explain to Charles why this compound is named this way? Any of you? Please go ahead and explain him because he's extra lost. He was lost and then he lost again.
What are we explaining exactly?
How you can name a compound like this or a compound like this or a compound like this to get this or to get this or to get this name. That's what you're explaining him.
To name a ketone, you figure out, well, for the first one, the 3-octanane, I'm going to go with the first example that we had. For the 3-octanon, yeah, you figure out where the ketone is or where the oxygen, the double bond oxygen is, and you count the number of carbons next to it. Are you comprende so far? Charles, is you understand so far? Okay, so on one side, you count the side with the most carbons next to it, excluding the one that the oxygen is connected to. So in the first example, you have 5 on one side. So that would be the longest carbon chain. So that would be pentyl, right? And it's connected to an ethyl, which is 2 extra carbons. So that would be the ethyl. You put it together in alphabetical order, and at the end, you put ketone at the end.
Okay, that's for the last method, right?
Yes.
Okay, let me assist you a little bit here. Regardless on which one is longer here, the one to the left or the one to the right, you focus on the alphabetical order. You know, you have an ethyl here and you have a pentyl here. So between the ethyl and the pentyl, which one comes first in the alphabet? The ethyl. So you name it ethyl, pentyl, ketone. Okay, considering that these are now branches connected to this carbonyl, which is the name of the functional group actually. Okay, and for the first method here, you
You just
count.
count the carbons.
Exactly. Go ahead.
You count the amount of carbons that is in the chain, and then you just put the number that the oxygen, the double bond oxygen, is connected to, either in the front or in the middle.
Yep. And then for the second method, Bianca, can you tell him how to do the one with the second method there? Can you?
For the second method, I just used the first version.
Oh.
I used the first version to answer the second method.
Okay, let me show you something quickly that can be very useful to you. And yes, this. You can also have, I'm going to delete everything for now, all right? You can also have something like this, and I explained this to you before. CH3, CH2, 6, CHO. Actually, let me put it this way. CO, CH3. Yeah. Do you understand what we have here? This 6 actually belongs.
Actually not.
This 6 is actually a subscript here. So we have CH3. We have the CH2 6 times. Okay, this is the same thing as saying CH3 and then CH2, CH2, CH2. How many times so far? 3. CH2,
3.
4, CH2, 5, CH2, 6. Instead of writing this 6 times, I can just put this in parentheses and then put the 6 outside, saying that I will have this 6 times here. All right. And then the CO and then the CH3. All right. This is the same thing as this. Do you understand what I just did?
Yes.
Yeah.
Okay, perfect. So this is basically the ketones. Now, let me tell you something. You might have the case of a Dione, and I'm not talking about Charles's mom. That's your mom's name, Charles, right? Dione, isn't it? You can also have something like this. Instead of having this here, we have this. What do you think we have here? This is a dione. How many carbons in all I have here? Can anybody tell me?
9?
9.
9 or 10?
9.
10? Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9, 9, 9, 9. So these 2, 6 dione. Okay, and I'm pretty sure you know why we have the die here, right? Why do we have the die here?
Because
Because there's 2.
And some people actually write it like this: no name dione, because you have 2 carbonyl groups in the chain, and this could be even tri. Okay, if I have one more, let's say here. Okay, oops, and that would be 2, 6, 8 donor trion. All right, so you can have more than one in the very chain. And is there any other name to name this? Yes, yes, you can. You can also put
That's
numbers.
2, 4, 8.
Huh?
That's 2, 4, 8.
Oh, yes, 2, 4, 8. Yes, that's true. Because now I have to start counting from this side. I started from this side and then I had 2 and then 6. Now, when I added this here, this was supposed to be 8, but now I have to start counting from this side. Why? Because if I start counting from this side, I will have 2, 4, and 8, and I will always have the lowest possible numbers. Okay, so this also, I'm gonna leave the dione for now. CH2, and this is di. Now name dione. I will also name this, remember, I can also name this like no name, no name 2, 4 dash on. Oops, dione. Okay.
6.
Oops, 6. Sorry. 2, 6 dione. Okay. Now, what I can't is to use the other method that goes like pentyl, butyl, blah, 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 blah. That one is going to be kind of hard here when you have 2 of them. So you can stick to these 2 methods. You can use any of them to name it. Right, and that is about the ketones. Again, the ketones have the ability, they're very good dissolvents. And that's why you can use it to remove paint, to remove nail polish. The acetone, by the way, is this is the acetone. Propanol. That's the acetone. By the way, this is the simplest ketone that you can ever have. You cannot have a ketone with less than 3 carbons. Can anybody explain why? Anybody knows why? Common sense. Why can't we have a ketone with less than 3 carbons?
Because the oxygen would be connected to primary carbons, which would make it a aldehyde.
That's correct. That's 100% correct. So propanol, which is C, and then here is where you are going to have the carbonyl. Carbonyl is the name of this functional group. And then here you're going to have CH3, and here you have CH3. So this is propanol. What is the other name for this? Any other name for this? For propanol?
2 propane.
You know, because you don't have to say 2-propanol, because it has to be 2-propanol. It cannot be in any other carbon. So when it's obvious, you don't have to state the numbers, all right? And in this case, that's the only possible chance. That's the only chance you have. the second carbon, because if it's in the first carbon, it's not going to be propanone, it's going to be propanol, which we are going to be talking about in a few minutes. So propanone, what is another name for this? Let me help you. Dimethyl
Yeah.
ketone. Okay, dimethyl ketone. Why dimethyl? Well, because remember I told you that when you're using this method, this becomes the center, the core, and whatever is attached to this is considered to be just a branch. So we have a branch here with one carbon, methyl. I have a next branch here with one carbon again. So you have one methyl here and one methyl here. You just group it and say dimethyl ketone. All right. And the same method that we're using here, we have to use it for other compounds that we call amines. We will learn about that next month, I believe. Yes, next month. For now, we are talking about the compounds that contain oxygen. Oxygen and the hydrocarbons that contain oxygen. That's what we're talking about. That's why we mentioned the alcohols. We're going to talk now about ketones and aldehydes. Later, we're going to talk about ethers and then carboxylic acids. So, is there any questions before I move to the aldehydes? Because I'm about to. I'm going to explain the aldehydes now. No questions? All right. If there is no questions, I'm going to explain the aldehydes. They also contain the carbonyl, and remember by carbonyl, I mean the double bond with the oxygen. Now, the only difference, as I stated before, is that this is not in a secondary carbon, but in a primary carbon. We're gonna have something like this. CH, you need to have the H because this guy has 4 bonds. Let me break it down for you because I don't want anyone to be lost. Remember that carbons have 4 bonds. So you have 1, you already have 1 here. You have 2, 3, and 4. 2 of them are together. And then instead of having 2 there, you might have 2 here with oxygen. And then you have 1 left for hydrogen. That's why at first I said that this, let me make this a little bit neater up here. Okay, that's why I said CHO, because you have the carbon, the hydrogen, and then the double bond with O. And this might be confusing because some people might do COH, and that can lead you to confusion. You might think that this is alcohol because you have OH, because you have the hydroxyl group, this. That's why people prefer to do CH and then O, so that you don't get confused and say, wait, is this alcohol? No, because alcohol is OH and this is HO. Aldehydes, let me type it here. Let me type the name here. I'm going to delete the red things so that you don't get, oops, that was not supposed to happen. Oops, wait. Hey, okay. Oh boy. All right, just remain there. I'm not gonna get crazy because of that. Just disregard the red bonds that I have here. So these are aldehydes, and the aldehydes, again, contain the same functional group as the ketones, but instead of having it in a secondary carbon, is in a primary carbon. So in this case, the name is very easy also. We have 1, 2, 3, 4, 5, 6, 7. The name for this compound is heptanal. That's it. You just add this suffix to the name, this ending, al. That's it for aldehyde, heptanal, period. If you have 1 more carbon here in between anywhere, that would be octanal, octanal. If you remove 1 from here, for example, what's the name for this now? Can anybody tell me? What's the name for that?
What's the prefix
Pentanol.
for aldehydes?
Repeat, Bianca.
Pentanol.
Yes, pentanal. Well, pentanal. There you go. Yep, that's it. Aldehydes. There's something that I have to tell you. For the common names, you will find something that goes like this. If you have a compound that has only one carbon, instead of having methanal, for example, you might have that they call this form, and this will be formaldehyde. That's the name for the methanol. They constantly, they very often use this prefix for the compounds that have only one carbon, form. And in this case, the methanol could be formal. They just decide to call it formaldehyde. By the way, this is the common name. This is the name that they give to this substance. Okay, this would be
that when you smell it, isn't that a thing that they put in dead people?
yes. This is actually a conservant substance. This is what they put to conserve. They put in corpses so that they don't decompose. This it has a retardant effect in the decomposition of organic substances. We went to a beach and we collected a lot of species of many marine animals, such as starfish, a lot of different fish, and we conserve them by using formaldehyde. Okay, it's the same thing as methanol. What would be the formula for methanol? Can anybody tell me? What's the formula for methanol?
CHO?
Hola, mami. CHO. That's, oops, sorry. Yeah, there we go. CHO. You're missing something. Can anybody help her? It's much more than CHO. And let me show you why. Have the C, have the double bond with oxygen, and then you have H, and that's it. Are you done? Are you done? This is what you told me to write, CHO. What is she missing?
There's another H.
Yes, another H, because it's 4 bonds that you will have for carbon. Okay, so it's CH2O. Wow, that sounds a lot like water, but it's not. CH2O. That's formaldehyde or methanol. Now, the same thing happens with the compounds that have 2 carbons. Instead of naming them ethan, and that's correct, ethanol, for example, they name this acet. I don't know if you have heard compounds that contain this prefix. Have you ever heard any compound with this name, acet?
Is acetone one?
Acetone, yes, that's correct. Have you ever heard a compound called acetaminophen? No?
No.
Never? Okay. There is one that is called acetic acid. Acetic acid, that's vinegar. But again, anytime you see a compound that starts with form, you know that refers to methane, 1 carbon. Acet refers to ethane, or 2 carbons. The ethanol is also called acetaldehyde. Same thing. This is just the common name. This is what people call it in the shop, in the store. If you go to a hardware store, you will probably find compounds with these names, because this is the common name for them. Formaldehyde, formic acid, formal, acetal, acetic acid, acetaminophen, acetyl, acetyl. The aspirin actually has this name. If you right now go on Google and type aspirin, you're gonna see that it has this starting, this prefix. Acetyl. Acetyl salicylic acid is the name for the aspirin. Acetyl salicylic acid. You will learn about that a little later. But acet refers to compounds with 2 carbons, and in the case of the aldehydes, it's not the exception. Commonly, you will find the ethanol called acetaldehyde. Anyways, what would be the formula for ethanol? Can anybody assist me with that?
CH3.
Huh?
CH2. I don't know. CH2O. CH3.
Okay, this is what you told me to do. I'm just gonna draw what you told me to do. I have a C and I have a next C. The first C has 2 hydrogens, 1 and 2, and it also has a oxygen. And then the next, and then the next carbon has 1 H. So this is what you told me to do. Is there anything you want to change?
Yes.
Okay, what is that?
CHO.
CH what? Hello?
CHO.
Okay.
CH3.
Yes, finally. This is ethanol. And now if we draw it, we'll get it. Now the last thing I'm gonna tell you is that you can have diols. And I guess you can easily tell me when you will have diols. This is when you have in the 2 ends of the chain an aldehyde. So you will have CHO here, and then CH2, and then CH2, and then CH2, and then at the end you have the same thing, CHO. Oops, this is supposed to be O. And what would you call this? We have 1, 2, 3, 4, 5 carbons. What would you call this? Pentane diol. And the di is because you have 2 in the 2 ends, 1 here and 1 here. Pentane diol. All right. Is that clear?
But you don't have to put the number, right?
No, because the aldehyde is always in the first and last carbons. Remember, if it's in the center, it's not an aldehyde. If it's in any other carbon other than the first, it's going to be a ketone and not an aldehyde. So you don't have to state the numbers here. If it's a pentane diol, is in 1 and 5. If it's a butane.
This class is about to end in like 30 seconds.
Okay. Then is butane diol is 1 and 4. Okay, so I'm going to ask you to join me back one time so that I can give you a couple examples before you leave. Okay, so join me back when the meeting ends.